As part of the previous section, we have gone through the details with respect to setting up required tables and also populating the data in those tables. The tables which are set up are nothing but these ones. This is the data model diagram for those tables. Now let us go ahead and understand the data model diagram, and also let us identify the relationship between the tables so that we can come up with queries as per the requirements. Once we understand the data model, then we'll define problem statement, and then based on the problem statement, we'll review SQL query capabilities. That being said, as part of the database, we have 6 tables. Even this data model diagram have 6 entities or tables. The tables are nothing but customers, then departments, categories and products, also orders and order items. When it comes to these tables, we can categorize into transactional tables and non-transactional tables. In this case, orders and order items are considered as transactional tables. When it comes to customers, departments, categories and then products, they are considered as non-transactional tables. Now each of the tables have primary keys and foreign keys. When it comes to orders, order ID is the primary key. Primary key means unique plus not null. When it comes to order items, order item ID is the primary key. When it comes to customers, customer ID is the primary key. When it comes to departments, department ID is the primary key. When it comes to categories, category ID is the primary key. When it comes to products, product ID is the primary key. The primary key fields are in bold, and also you have PK at the end. On top of primary keys, some of the tables also have foreign keys. For example, when it comes to order items, it have 2 foreign keys. One foreign key is from order item order ID to orders order ID. Another foreign key is from order item product ID to product ID. In the similar manner, we have foreign key between orders and customers using order customer ID in orders and customer ID in customers. When it comes to foreign key constraints, you need to make sure you understand the logic behind them. First, you need to identify the relationships. Based on the relationships, you should be able to figure out how foreign keys are defined. If you think about orders and order items for applications like Amazon or Flipkart, then for each order, you will have order level characteristics. The order level characteristics are nothing but customer ID who have placed the order, date or time at which the order is placed, and also the status. On top of these things, you can think about other attributes at order level. However, when it comes to one order, there can be n number of items in it. It means one order can have one or more order items. If you think from the relationship perspective, there is one to many relationship between orders and order items, because one order can have one or more order items. In the similar manner, one customer can place multiple orders over a period of time, and hence we have one to many relationship between customers customer ID and orders order customer ID. From the customers to orders, we have one to many relationship. From orders to customers, we have many to one relationship. Based on many to one relationship, we define foreign key. In this case, I forgot to mention FK after order customer ID. Actually, this is foreign key field to customers customer ID. If you observe the connector, you have one here, you have many here. Fork means many. As orders can have multiple order items, we have one to many relationship between orders order ID and order items order item order ID. If you think from order items perspective, we have many to one relationship between order items order item order ID and orders order ID. In the similar manner, when it comes to products, products can be part of many order items over a period of time, which means we have one to many relationship between products and order items. The relationship is between products product ID and then order items order item product ID. You need to make sure you observe these connectors and understand the relationships between the tables so that you can come up with appropriate queries in case if you have to join multiple tables. Spend some time and make sure you can interpret these data model diagrams. It is very, very important for you to be able to interpret data model diagrams so that you can write queries effectively. In case if you are not comfortable with data model diagrams, I would highly recommend you to spend some time and make sure you practice enough. I'll not be covering too many details as part of this course, but I will emphasize that you should understand the data model diagrams. You don't need to worry too much about coming up with data model diagrams because it is typically taken care by data architects who work closely with the business. As engineers, you should be able to interpret data model diagrams, especially the relationships between the tables. That being said, using this knowledge, let's go ahead and come up with the problem statement, and then let's come up with a solution for the problem statement. In that process, we'll understand how to write queries effectively.